Why is studying quadratic equations important? Quadratic equations are used to find the path that objects take when they fly through the air. The quadratic equation is used to determine how safe products are and the life expectancy of products, such as when they can expect to quit working. Speakers send out sound waves, and these waves vibrate, sometimes causing unwanted cancellations of sounds. Designers use the quadratic equation to redesign the speakers and circuits so that waves reinforce each other. Quadratic equations explain how planets in our solar system revolve around the sun. Police officers use the quadratic equation when investigating a car accident scene to determine what speeds the cars were traveling when the collision occurred. Car makers determine how much and what type of brakes are needed to stop a car going at various speeds using the quadratic equation. The military uses the quadratic equation when they want to predict where their artillery shells will hit. In the 1950s, Homer Hickam used the quadratic equation to defend his claim that a rocket that he fired did not start a fire. The true story of Homer and his interest in rocketry is told in the movie October Sky.
Why don't you let the boy defend himself?
And in the second place, this rocket proves nothing. You've already admitted having lost a number of your rockets. You cannot prove conclusively that another one of them didn't start that fire.
Yes, I can.
Oh. Are we to conclude, Mr. Hickam, that since leaving school, you've not only become an expert in rocket science, but in the field of trigonometry?
I didn't say that. I was
Obviously, you learned more in the coal mines than you did in high school.
Let the boy talk. Go ahead, Homer.
Now, the fire was near Welch, just under 3 miles from our launch pad. And at the time of the fire, the best that we could do was 1.2 miles, which is exactly where we found that rocket, Mr. Turner. See, Mr. Turner, that rocket fell for about 14 seconds, which means that it flew to an altitude of 3,000 feet. According to the equation, S equals 1/2 AT squared, where S is the altitude, A is the gravity constant of 32, and T is the time it took for that rock to come back down. Velocity equals acceleration times time. Well, are you following this, Mr. Turner?
All right, we're all duly impressed. But do you mind telling me if you did not start that fire, who did?